Good day, I'm Mr. Ulysses S. Garcia Jr. I'm going to discuss and present to you my study entitled 7C'S of the 21st Century Skills, Assessing the Learning of Grade 11 Science, Technology, Engineering, and Mathematics Students in Statistics and Probability at Far Eastern College, Silang, Incorporated. To start this presentation on this background of the study, we all know that our learner is on the Generation C and actually the 21st century learners. On this specific case, P21 framework for the 21st century learning serves as the framework that the teachers, educators, or the school will consider in terms of honing the skills of the students. On this P21 framework, it actually talks about how the school, how the teacher deal with the needs of the students. According to Bishop 2010 on the Partnership for 21st Century Skills, it actually states that there are different skills need to acquire towards with the lifelong learning. According to the Center for Curriculum Redesign on 2015, there is a fundamental question on the 21st century. And this would be, what should students learn for 21st century? And according to Michael Dell 2010, that to compete and to win with the global economy, the students need to acquire different set knowledge and skills. The 21st century has brought with its fast-paced, complex environment. In order to excel in this ever-changing world, young adults need to be capable of thinking critically, to be creative, innovative, and adaptable. Consequently, on this study, it is not enough to see only the learning of the students through the scores that the students gained or the different competencies that the learners targeted. But the researcher aims to assess the learning of the grade 11 students aligned to the 21st century skills, or the 7C'S, that will serve us, and the researcher produce a questionnaire that will serve as the framework if the students obtain different 21st century skills. And by answering these questions presented on the survey questionnaire, if there is a significant difference on their grades obtained to their profile and to the 7C'S of the 21st century skills. And one of the main goals of this study is to determine the significant predictor of learning of the students in 7C'S of the 21st century. This is the statement of the problem of the study that will further discuss with the latter discussion or presentation. For the methods and materials, first, the researcher identified the competencies of statistics and probability. The second one, the researcher create a survey questionnaire, which leads to the third step, validation and approval of period, which actually the researcher contacted 3 experts from the field. And the next one would be the data gathering. The researcher used Google form and distributed 133 respondents. Next one is the evaluation and assessment of findings, and the last one, conclusion and recommendation. The researcher used quantitative research design for this study, and the instrument is survey questionnaire, and the sampling technique is purposive. Here are the statistical tools used by the researcher for different statement of the problems. For statement of the problem 1, what is the demographic profile of the respondents in terms of the following: age, sex, section, grades in statistics, and probability? For the age, most of the respondents are on 17 years old. For sex, most of the respondents is on male. And for section, most of the respondents are on the section STEM 1-3. And for their grades, most of the respondents are on the mark of 81 to 85. For statement of the problem number 2, what are the defined 21st century skills gained by the STEM students in learning statistics and probability? For critical thinking skill of STEM students, most of these respondents answer that they can connect the prior knowledge to the recent introduced topics in the subject, statistics and probability. And to summarize the references presented on this presentation, that it implies that the students draw critical thinking by drawing out the prior knowledge to the new introduced topics. And prior knowledge informs critical thinking in multiple levels, which means and signifies that if the students acquire this skill, they think above thinking. And this is the most essential skill, one of the most essential skills that the students need to acquire in order for them to successfully appreciate and deal with mathematics. If the teacher successfully process the connection between the prior knowledge and the recent introduced topics, it actually draws the students' deepen understanding and engagement in class. For Table 6, creativity skill of STEM students, they answer that they can determine the patterns in mathematical situations about the subject, statistics, and probability. And for the overall, they acquire the high speed. According to Vogstad 2015, in his journal, Patterns in Mathematics, that understanding and being able to identify the recurring patterns allow us to make educated guesses, assumption, and hypothesis, which leads to creativity. And it also says on the Journal of Man 2006, entitled Creativity, the Essence of Mathematics, that talent development requires creative applications in the exploration of mathematics. Most of the traditional teaching methods involves demonstration and practice using closed problems and predetermined answers that insufficiently prepare students in mathematics. It means that teaching mathematics without providing creativity denies all students to create and to appreciate the beauty of mathematics and fails to provide students fully developed talents. For table number 7, communication skill of STEM students, on the descriptor, I can analyze and evaluate mathematical thinking and strategies of others. Communication is one of the skills that students need to gain to achieve a lifelong learning. According to Professional Standards of Mathematics 1991, that the classroom should encourage students to discuss their ideas, respect and value student thinking, and encourage exploration of mathematical ideas. This implies that if the students can analyze and evaluate mathematical thinking and strategies of the others, actually they can stimulate good communication. And according to National Council of Teachers in 2001, that communication is an essential part of mathematics and mathematics education. It is a way of sharing ideas and clarifying and understanding. Through communications, basically, ideas become objects of reflection, refinement, discussion, and amendment. The communication process also helps build meaning and permanence for ideas and makes them public. Actually, if the students can analyze and evaluate mathematical thinking and strategies of others, they can acquire different skills that they need in order for them to successfully appreciate the beauty of math or manipulate the mathematical concepts. For table number 8, collaboration skill of STEM students, most of the respondents will agree to this descriptor that they can discuss their errors and accept the corrections of my colleagues in answering problems about subject, statistics, and probability. According to GoHack 2013, the president of NCTM, or National Council for Teachers in Mathematics, that helping students to learn from their mistakes, they can give insights on their misconceptions and develop deeper understanding of the mathematics they are learning. Actually, collaboration allows the students to explore things and learn from the others' experiences and ideas. One of the important statement that Retnowati et al. 2017 in their study, Can Collaborative Learning Improve the Effectiveness of Work Examples in Learning Mathematics? Results show that the effectiveness and collaborative learning was important in dealing with complex tasks. High complexity problems were argued to increase active social interaction during collaborative learning, which is actually, if the students collaborate to each other, they're sharing ideas, they can accept their errors, there's a value there. If the teacher allows the students to collaborate to each other, there is a platform that they can share ideas, they can correct themselves, they can gain insights from the students. If the teachers provide this platform in collaboration, actually learning happens. For table number 9 discussion, cross-cultural understanding skill of students, it's actually summarized the point that there are two primary goals in the success of math. The first one would be acceptance of self, and the second one would be the acceptance of others in terms of differences and similarities. Student acceptance and representation through dialogue to understand differences and similarities of people with respect to attitudes, knowledge, and behaviors are very important in learning and appreciating beauty of mathematics. If the teacher assesses the students in terms of this skill, actually the teacher is leading them to connect to the different platforms, to the different cultures in terms of the foundation of mathematics. For table number 10 about computing and ICT literacy skill of the STEM students, it actually stated that if the teacher emphasized the importance of students reasoning about mathematics and solving problems, it's also stressed that the point of generating and evaluating knowledge, ideas, and possibilities, and using technology when seeking a solution provides the students to think more of what expected to them. It actually, if the topic or if the problem is research-based instructional strategies combines with appropriate innovative technology application, actually learning happens. For table number 11, career and self-reliance skill of STEM students. According to West Virginia Adult Education 2018 on identifying strengths and weaknesses, it is important to determine strengths and weaknesses first, to know what goals will be realistic and how to proceed with the plan of the study. It's actually if the students know to them their strengths and the other things that they need to improve, actually they are being realistic to it and they can proceed with their plan of study. In addition, according to Fatima 2013, that in education system, mathematics plays an important role in shaping the future probability of young people and education. And this is to develop an individual to make her or himself reliant to study mathematics. To summarize, on table number 12, the overall 21st century skills of the STEM students, which actually gain a high skill with a mean of 3.05 and the standard deviation of 0.30. According to Escobar 2015 on his journal about what is the 21st century learning. As such, students and classrooms need to be transformed into global, where variety of cultures are explored and discussed, as the teachers inspires the students to become a lifelong learner. For statement of the problem number 3, is there a significant difference in the performance of STEM students when grouped according to profile? For the table 13, performance of the STEM students according to profile, age and sex has significant difference with the given predetermined 7C'S of the 21st century. The test statistic for the age would be ANOVA, for sex is t-test, and section would be ANOVA. And section actually has no significant difference on the performance of the STEM students. For statement of the problem number 4, which of the 7C'S is or are the significant predictor of STEM students in statistics and probability? On table 14, 7C significant predictor of STEM students. As you can see, using regression analysis, on the p-value 0.041, actually there is a significant predictor of learning in statistics and probability that will tackle the 7C'S. And I've shown with this post hoc test that only the critical thinking with the p-value of 0.026 is the significant predictor of learning to the STEM students anchored with the 7C'S. Among the 7C'S given, only critical thinking is the significant predictor of the STEM students. In conclusion, for SOP number 1, age was 16 to 17 years old. Majority are males. Most of the section came from STEM 1-3 rather, and the final average was in the range of 81 to 85. For statement of the problem 2, the conclusions are most of the results are in the high skills. In terms of assessing the students in terms of 7C'S, most of them, or on the 133 respondents, acquire the high skills. STEM students are agreeing on to all skills with the mean of 3.05 and the standard deviation of 0.30. And the responses on the assessed skills imply that the students are toward lifelong learning. In conclusion, for statement of the problem 3, data shows that there is a significant difference on the assessed learning or performance of the students on the age, which actually 0.005 is less than 0.05 and sex 0.00 is less than 0.05. It implies that Generation C is found to be independent, competitive, and cognizant. And for statement of the problem 4, using regression analysis, the model is significant with a p-value of 0.041, which is less than 0.05. Significant predictor of the assessed learning of the STEM students in the subject statistics and probability is critical thinking with a p-value of 0.026, less than 0.05. For the recommendation, after assessing the skills of the students anchored with 7C'S in the 21st century, one of the recommendation is the 7C'S should be measured across to the different mathematics subjects, not only with the subjects statistics and probability, because if we're going to gain the success of mathematics in terms of lifelong learning and competitiveness and effectiveness of mathematics in their lives, we need to assess the students across with the different mathematics subjects. The second one would be strengthen the program of aligning the mathematics curriculum of the school in addressing the needs of the 21st century learners. As we've seen with the statement of the problem 4, only critical thinking is the significant predictor of learning, which is actually a positive one because critical thinking is the umbrella of all the skills provided in the 21st century skills. However, there are different 6 skills that the teacher or the school need to strengthen for them to acquire, for them to achieve the 7C'S, that the needs of the 7C'S in 21st century skills. Create an enhancement program and varied activities, whether individual or group, that will assess the learning in statistics and probability to draw out the other significant predictors. That the school or the teacher can provide different varied activities for the students to draw creativity, communication, collaboration, and other significant predictors of the 21st century 7C'S. And for the last one, revisit the syllabus and modules created by educators of mathematics of FEU Cavite. On this specific recommendation, we need to integrate some of the descriptors presented on the survey. The school might consider the different skills that they need to focus with, like for example, integrating the ICT to the subject of statistics and probability, not only with the subject of stats and probability. Like for example, I've mentioned that this survey or this self-assessment, the school can use this for other mathematics subjects or across, because this type of assessment, not just only by numerical value, the score of the students. If we're going to assess the students in terms of this kind of self-assessment test, it actually leading the student in the lifelong learning or towards lifelong learning, and the students become locally or globally competitive, and their and they can be independent, they can be cognizant, that they can be self-directed, and other skills will follow. And here are my references. And that's actually the end of my discussion on the study 7C'S of the 21st Century Skills, assessing the learning of grade 11 science, technology, engineering, and mathematics students in statistics and probability at Far Eastern College, Silang Incorporated. Thank you very much and God bless.